Hello, everyone. My name is Ramona Irie. I work at NAFAC Exwick in Port Hueneme, California, and I would like to thank you for attending the Open Environmental Restoration Resource webinar on the Remedial Investigation Framework Overview for PFAS. Our speakers today are Kendra Clubb from NAFAC Northwest and Alex Scott from NAFAC Washington. So now a little about our speakers. Kendra Clubb graduated from the University of Colorado with her master's in civil engineering with an environmental engineering emphasis in 2008. Kendra has worked for NAFAC Northwest Environmental Restoration Program since 2008, during which she has worked on various projects in remote Alaska and on Whidbey Island, Washington, and most recently took on the role as Northwest's PFAS lead RPM. In her spare time, she enjoys hiking, running, biking, and gardening. Alex Scott has been with NAFAC Washington since 2016 as an RPM. Although his career in environmental science began in 2004, shortly after graduating college, he realized that the fascinating work of environmental investigation and remediation under CERCLA required more advanced education and a PE license to credibly work on the projects he wanted. He received his master's degree from Johns Hopkins University in Baltimore, Maryland in 2009 and the PE license from Maryland in 2012. Outside of work, he enjoys stand-up paddle boarding at as many lakes, rivers, and beaches as he can until the weather is suitable for snowboarding. Kendra and Alex will be presenting on general guidelines that the Navy has updated for PFAS remedial investigations. These guidelines address a variety of topics that come up during the RI, including site characterization, analytical methodology, addressing investigation-derived waste and off-base drinking water exposure. At the end of the presentation, we will be having a Q&A session. Participation is voluntary. We highly recommend that you submit your questions throughout the presentation via our chat box. This presentation is being recorded, and the recording will be posted onto our public website. Following the webinar, a link will be available to a short survey. Please fill out the survey as it is our main feedback mechanism and should take less than 2 minutes to complete. Next slide. I want to emphasize the following important disclaimer. This webinar is intended to be informational and does not indicate endorsement of a particular product or technology by the Department of Defense or NAFAC Exwick. Although every attempt is made to provide the most accurate information, there is no guarantee that any technology or product will be suitable for your site. Before our speakers begin the presentation, I would like to invite Kim Parker-Brown from NAFAC headquarters to say a few words about the OER2 webinars.
Thank you, Ramona. And hello all. As Ramona mentioned, I'm Kim Parker-Brown. I'm an environmental engineer and environmental restoration program manager with NAFAC headquarters in Washington, D.C. And we at NAFAC really appreciate your participation in our OER2 webinar series. We've been providing this series since about 2014, and we look forward to providing another informative topic for the environmental community today. This webinar series is for our RPMs, our RTMs, contractors, and others who support the Navy's Environmental Restoration Program, or our ERP program. Our goal is that the series will provide a venue for two-way communication from both reaching out to and obtaining feedback from the community members. The emphasis of the webinar series is to share information openly and to promote innovations among the environmental community. This is done via our Navy policies, guidance, tools, our technologies, practices, initiatives, or in our lessons learned. And we'd also like you to know that feedback from our environmental community members is key to sustaining this webinar series. So please feel free to recommend topics or to volunteer as presenters. Any topic which is considered should be relevant to the ERP, and it should not contain any marketing materials, as Ramon had stated about with our disclaimer. If your topic is selected, you will be working with the Navy champion, and the community member may present the topic possibly with the Navy POC. Now, today's webinar, which is on our updated and our revised interim guidelines for PFAS remedial investigations, or RIs, is a very crucial topic for the ERP, in that currently the Navy is completing our base-wide PASIs on our Navy installations. And of course, our next step would be to move to the RI phase in the circle process for many of our bases. We have several, well, actually, we have hundreds of existing, new, and reopened sites for our PFAS RIs. So these guidelines are key in providing scenarios which we believe will be encountered on our PFAS installations. This webinar is being presented to provide information on the planning and the characterization of RIs, and to provide direction and recommendations in working to complete them, along with providing an understanding on how they apply to DoD's policy and guidance. So with that, I'd like to pass it over to today's presenters, Ms. Kendra Clubb and Mr. Alex Scott. So Kendra, please take it away.
Thanks, Kim. Good morning and afternoon, everyone. Thank you for joining our webinar today on the interim general guidelines for PFAS RIs. This is the first part of a two-part OER2 series. The next part will include lessons learned for actual PFAS RIs at a couple of Navy installations. We hope you can join us for that next webinar. It'll be very informative. Next slide, please. As is the case with all DoD presentations, we have a very large list of acronyms for words that are used throughout the presentation. Just a quick snapshot here of all the acronyms that will be used during the presentation today. Next slide, please. The purpose of the presentation today is to provide an overview of the general guidelines for PFAS RIs provided in the revised PFAS RI guidance document developed for RPMs from the Emerging Chemical Work Group. This document is not intended to be prescriptive or binding in nature. There will always be site-specific topics that are not covered in the document. All RPMs, or remedial project managers, should continue to review other documentation to support their RIs, such as the Department of the Navy Environmental Restoration Program Manual, called the NERP Manual from 2018, Navy and DoD PFAS guidance and policies, and EPA guidance on RIs. The links on the Navy and DoD guidance and policies is provided at the link on the links below. Next slide, please. This slide just shows an overview agenda of the presentation for today. We'll start off talking about off-base drinking water. Then we'll move into general RI planning, site characterization, risk assessments, fate and transport, background or non-Navy PFAS sources, investigative-derived waste, and then we'll wrap up with some Q&A. Next slide, please. The potential for drinking water exposure near our installations continues to be the #1 priority. The evaluation of on-site data and potential impacts to off-base drinking water sources needs to be continuously reviewed throughout the CERCLA process. RPMs should evaluate all RI data, such as new areas of concern, PFAS groundwater results, the groundwater flow direction, all to determine if a new drinking water exposure pathway has been identified. For example, if on-base groundwater data indicate PFAS and/or PFOA above the approved screening levels for drinking water, groundwater flows off base, and groundwater is used for drinking water either on or off base, you must notify your leadership immediately. And please note, at this time, 70 parts per trillion, PFAS and PFOA, individually and combined, remain the DoD's action level for drinking water response actions. If your RI data indicates an off-base investigation is needed, as I said, reach out to your leadership and your subject matter experts immediately. The off-base drinking water investigation will need to be conducted in parallel to your internal draft RI report. Also, Navy RPMs must remember when and if an off-base drinking water sampling investigation occurs, this information must be reported monthly and quarterly per the National Defense Authorization Act requirements. Next slide, please. RPMs should prioritize their PFAS RIs consistent with the rest of the Environmental Restoration Navy program, and that is using the relative risk screening evaluation tool. Prioritization should be discussed with their leadership and ultimately coordinated with the NAVFAC headquarters prior to finalizing a budget plan. Doing an RI for PFAS is pretty much the same as doing an RI for any other chemical. However, there are some considerations specific to PFAS, which is the focus of the presentation. And while the state of the science may make it difficult to complete a PFAS RI, it is important to plan for and scope a comprehensive RI to ensure sufficient data is collected to execute the RI completely. However, complex sites may require multiple iterations of site characterization to complete the RI process. The figure on the right side of the slide is from the 2018 NERT manual. It is a standard part of the RI process to collect additional data as needed to refine the conceptual site model and evaluate risk. When preparing sampling analysis plans for PFAS RIs, sampling of various media to refine the conceptual site model should be considered as part of your data quality objectives. However, where necessary, abiotic sampling, such as sediment and surface water sampling, should occur prior to biotic sampling, such as tissue sampling. Please always consider the latest screening values based on the latest toxicity information provided by the EPA and as approved by the DoD and posted on the OSD's website, and that website is shown here. Other items that are part of the RI planning process include non-Navy PFAS sources and off-base delineation. These topics are discussed further in the upcoming slides. Next slide, please. RPMs should analyze the groundwater, surface water, and soil and sediment and biota as necessary via draft method 1633 for all RIs going forward and awarded after August 7th of this year. And that is per the August 7th memorandum that was published by ASD. At this time, there are no DoD ELAP certified analytical methods available for air. So air is not able to be analyzed at this time as part of RIs. The memorandum that I mentioned also allows for PFAS screening methods to determine the presence or relative concentrations of PFAS with the approval from a DoD project representative. The use of the screening methods are prohibited for analysis of samples used for regulatory compliance, risk assessment, or comparison to project screening or action levels. Please refer to the DoD Environmental Data Quality Work Group Screening Method Implementation Guidance on these screening methods, and that document is dated September 27th to
Kendra, I think we lost your audio.
Can you hear me?
I can hear you now, yes.
Oh my, oh good. All right, crisis averted. Thank you. So was it at the human health that you lost me? Or was that at the very beginning of the slide?
It was not at the very beginning of the slide. Go ahead and start at human health. That sounds good.
Okay. So for your human health screening values, we should be using the risk-based screening levels for PFAS, that are the vetted values per the ASD memo of 2024 August of this year. But as always, please check the EPA RSLs and the OSD website to reevaluate if those levels have changed throughout your remedial investigation. For ecological screening values, please use the Emerging Chemical Workgroup Interim Final Issue Paper ESVs, or ecological screening values. The selection of the ESVs should be reviewed with your project consultant's ecological risk assessor and appropriate NAVFAC SME. And due to the uncertainty of how this data will be precisely used in the RI to make decisions and in future CERCLA phases, please include an uncertainty analysis section in your RI work plan for that type of sampling. And as I said, reevaluate throughout the RI to see if those levels have changed so you're using the most up-to-date levels. There are some states that have state screening levels or promulgated cleanup levels for PFAS. The evaluation of state standards as potential ARIs, or applicable or relevant and appropriate requirements, is performed during the feasibility study consistent with CERCLA. However, when establishing RI data quality objectives, RPM should attempt to establish detection limits that are low enough to compare site data to state levels in case they are established as ARIs during the feasibility study. Next slide, please. For off-base investigations, RPMs must coordinate closely with their leadership, legal counsel, and real estate staff before initiating an RI off DoD-owned property. There are two possible paths or routes for securing off-base agreements. The first is a real estate access process. The second is a CERCLA 104 administrative order. For the latter, it is critical that all RPMs consult their legal counsel and their leadership and headquarters prior to proceeding with a CERCLA 104 access authority. The process for both types of agreements can take considerable time, greater than 12 months in many cases, so plan accordingly. Real estate actions may also require program funding, depending on the type of agreement. An easement or a lease will require funding, so keep that in mind and consult your Navy real estate office early. And please contact your ER manager or other leadership about the most current controlled unclassified information guidance on how to properly mark these project documents and access agreements. For transferred sites, you must also consider the existing land agreements with property owners. Next slide, please. Human health risk assessments. The figure on the right is from the NERP manual that I mentioned prior, and we should be following this process for all the PFAS human health risk assessments. As I've mentioned prior, RPMs should use EPA vetted and DoD endorsed toxicity values to select their project action limits to determine if further evaluation is warranted at a site. And given the evolving nature of toxicity pertaining to PFAS, and it is important to review the screening values during the preparation of your HHRA to determine whether there are updated values that you should be using. Please consult your SMEs early and often during planning and execution of your RIs. Next slide, please. Ecological risk assessments. The figure on the right is also from the 2018 NERP manual, and we should be following this process for PFAS ecological risk assessments as well. However, there are unique challenges associated with conducting PFAS ERAs. So keep that in mind and consult your ecological SMEs early and often during your RI planning and execution. Planning for and completing a screening level ecological risk assessment and a baseline ecological risk assessment should be considered evolving. There are current ESVs available for use in screening level ecological risk assessments, but the toxicity reference values, and thus the ESVs, are subject to change as more studies are completed and data gaps are filled based on the most recent peer-reviewed literature. At this time, I will hand the presentation over to Alex Scott for the remainder of the slides. Alex?
Yes, thank you for that excellent presentation, Kendra. So the remaining slides are intended to provide recommendations and considerations when planning and scoping your PFAS RI. The technical details of investigating PFAS at a site are too complex and too involved for the purposes of this presentation today. This part is intended to highlight key points and support environmental practitioners performing PFAS RI projects for NAVFAC and discuss some of the technical content within the 2023 NAVFAC Interim General Guidance for PFAS RI document. However, it is not comprehensive of everything within the document, nor it is intended to prescribe how to sample your site or endorse one methodology over another. So I want to start with fate and transport. So fate and transport of hazardous substance releases at your site is fundamental to planning an RI's technical approach. Briefly summarized, fate is how a chemical persists or changes form in the environment. Mechanisms such as chemical, physical, and biological mechanisms can be important to this transformation. The transport is how a chemical migrates within and between the environmental media. Now, PFAS has peculiarities which are unlike other chemicals we may be more familiar with, such as VOCs, fuels, metals, etc. Considering these unique properties of PFAS and how they affect fate and transport and the various environmental media provides for a more representative conceptual site model. I'll be using the abbreviation CSM. And it leads to more informed, robust, and defensible results to characterize the nature and extent of a PFAS release at a site. A key consideration is that a release of PFAS typically contains multiple constituents. Although all PFAS are chemically similar and they have hydrophilic heads and hydrophobic tails, each different PFAS chemical may have differing fate and transport characteristics even in the same environment, which can complicate your CSM. Next slide, please. So partitioning and complexity. So how PFAS partitions in site media is key to understanding that constituent's fate and transport. It indicates how PFAS may be stored, retard, re-release, spread, and redeposit at a site. Both subsurface and above ground features of a site may have these characteristics that ought to be considered in your conceptual site model. The PFAS partitioning has a number of mechanisms to consider which may differ chemical to chemical. These include, but are not limited to, these are just some highlights. So how PFAS will stick to soil layers and even individual soil particles. This is important because mass storage of PFAS can occur within any particulate environmental media at a site, such as the Veda zone and aquifers in the subsurface, or above ground within deposited sediments and migration of those sediments over land on particles during storm events. PFAS constituents have varying solubility in water, and it can determine how much PFAS remains on soil particles and how much is dissolved into the water, influencing PFAS behavior in the groundwater and surface water media, and observe concentrations of these dissolved quantities. This also has an effect on leachability of PFAS in the Veda zone. PFAS also have electrostatic effects that differ from molecule to molecule. Charged molecules like salt and media particles like clay can affect the mass storage as well. And each individual PFAS chemical may have differing properties of charge. Consider that PFAS chemicals may be anionic, negatively charged, cationic, positively charged, or polar, or zwitterionic, as you'll see in the literature, and there are non-ionic constituents as well. Additionally, relevant to PFAS is the air-water interface in the site's media. Essentially, this is how constituent PFAS chemicals, foam, affect the surface tension and form colloids, which are important clues to how it migrates in the media. These are typically discussed as micelle effects in technical papers. So there's a transformation as well. PFAS chemicals can degrade or transform in the environment, and it is also important to consider how they may transform inside your receptors. Considering the different PFAS constituent affinities to sticking onto organic carbon is also an important partitioning also important to partitioning. How humic your site media may be under investigation can substantially or significantly affect this partitioning mechanism. Also, let's not forget about plants. PFAS chemicals can also have different affinities for plant uptake and storage. Essentially, all these factors affect how far away and how far below PFAS will migrate in media and influence the concentrations of PFAS in your analytical sample results. However, not all mechanisms discussed above have proven an effective field and analytical methods to quantify their effects. Next slide, please. It can be a little tricky. So I wanted to discuss a little bit about the differences between PFAS chemicals to consider during your planning and executing your PFAS RI project. The key takeaway is that different PFAS migrate at variable rates. So sampling locations and groundwater well networks should reflect likely different plume extents. So why is the subsurface so important? From past defense environmental restoration program experience, we'll say ERP, or ERP, the majority of cost and effort of a PFAS RI will be in characterizing the PFAS nature and extent in the subsurface media. In planning and scoping your PFAS RI, consider these differences between the PFAS molecules themselves, as it will support the sampling strategy and likely improve your investigation outcomes. So going a little more into carbon partitioning, the hydrophilic heads of PFAS usually have one of two functional groups. PFAS with sulfonate have PFAS with a sulfonate functional group, such as PFOS or PFOS, known as perfluorooctane sulfonic acid. These tend to stick to organic carbon with more affinity than PFAS with the carboxylate functional group, which often has an A at the end, like in PFOA, which is perfluorooctanoic acid. So additionally to consider for carbon partitioning is the size and length of the tail chain of your PFAS. Those PFAS that have, so many PFAS that we look at, like that have 8 carbon, has an 8 length carbon, or has an 8 carbon length chain, with the octanoic in there, preferentially bind and retain within humic media, more so than the shorter chain PFAS, like the ones that contain 3 carbon, the propylene ones like Gen X. And if you must, it's also known as hexafluoropropylene oxide dimer acid in the literature. And moving on to a little bit about the differences in electrostatic effects and how they affect storage and retardation in the subsurface and in the environment. So cationic and so the positive ones and zwitterionic PFAS have more affinity to absorb to charged clay particles, and we even see this behavior in mildly charged soil particles. This can lead to long-term retention and storage of PFAS contaminant mass in the subsurface that may not be indicated in the dissolved fractions in your groundwater results. So for many Navy environmental restoration sites, the primary PFAS release we're concerned about is AFFF, or their aircraft firefighting foam, or aqueous firefighting foam. So fortunately, ionic and polar, or an important consideration is that the ionic and polar PFAS molecules typically compose 95 to 97% of the mass of AFFF formulations. However, portions of that AFFF contaminant mass may be non-ionic and travel farther than charged PFAS in subsurface media. It's important to consider it. It's important to consider it all, not just the bulk. Next slide, please. So what do we do with trying to keep all of this PFAS RI complexity straight in our heads and focused during the planning and scoping sessions, where the data and also when data informs and updates our CSM as our investigations progress? So the key point is always that I want to stress is that work together as a team with your subject matter experts to make sure the project quality objectives are clear in your sampling and analysis plans. Also, work together in your partnering teams to obtain agreement on how data will be used. It doesn't serve us to have contention between the Navy and our regulatory partners when it comes to these PQOs, because clear PQOs cut through the complexities to answer key environmental and risk questions that are critical in developing suitable and effective remediation strategies. So I just wanted to talk about the figure on this slide. It is a cartoon of a CSM where fate and transport characteristics for PFAS are considered in various media. Assessing your media's characteristics is important to understanding fate and transport, and it can help disentangle PFAS complexities and result in better data usability and analysis that is more representative of site conditions. And an issue that many PFAS RI sites may possess is the transport of PFAS contamination from one media to another. Where this is important, it can be challenging to assess and measure using only and when you measure or when you try to interpret this mechanism using only field interpreted soil borings and groundwater monitoring well samples, it can be challenging, and data gaps could arise. So at sites where this is important, consider some of the assessment technologies we've listed in the RI technology tables within that 2023 interim general guidelines for PFAS RI when you are planning and scoping PFAS RI. For example, lysimeters may be useful at your site for measuring how PFAS leaches in the vadose zone and to infer the flux of PFAS moving from unsaturated soils to groundwater media. There's also various passive flux meters, and when placed strategically in groundwater media, may be useful in measuring the mass flux of PFAS through the aquifer units and its potential transport in surface water. Next slide, please. I wanted to, so understanding PFAS migration and storage in the environment is critical. The previous slides focused on partitioning, storage, and migration considerations. However, there are complexities to the fate of PFAS molecules in the environment. PFAS encompasses a large group of chemicals, and while some molecules remain forever in the environment and don't change, some constituents degrade and transform into other PFAS constituents. These transforming PFAS are sometimes referred to as PFAS precursors in the literature. PFAS site investigations, or SI, phases that the Navy completed in 2023 and prior years focused their analysis and discussion of the analytical results of PFAS constituents where risk-based screening levels, or RSLs, were calculated by the EPA and accepted by the DoD in the July 7, 2022 ASD memo, and it included only 6 PFAS constituents of concern. So these were critical to establishing those clear PQOs for SIs to collect evidence for the presence or absence of a release of PFAS into the environment that presents a potentially significant risk. Luckily, most of the Navy SIs with fieldwork in 2022 and 2023 used the draft analytical number 1633 method, which included a list of 40 PFAS constituents, some of which are precursors. In some cases, precursor concentrations can be orders of magnitude above their breakdown products and can inform you more about your source area than is evident from just the compounds with RSLs. And these breakdown products can often include PFOA and PFOS, as well as other PFAS that do have RSLs. So the key to consider, or therefore it is key to consider all site analytical data collected prior to scoping your PFAS RI, not just that analytical data for PFAS that have RSLs. Don't ignore them. Precursor breakdown products may create PFAS concentrations that are higher in downgradient areas than the physical chemical retardation and mass storage would predict. Also consider that biotransformation of precursors within organisms is also possible. Next slide. So all PFAS RIs must be linked to a Department of Navy PFAS release to be eligible for Environmental Restoration Navy or base realignment and closure funding under the Environmental Restoration Program. The 2023 Interim General Guidelines for PFAS RI provides considerations for assessing background and non-Navy sources of PFAS. And some of the highlights are that this background analysis may be necessary to demonstrate that areas of a site are not impacted by the Navy's PFAS release. And for sites with urban waterways or other water systems that receive PFAS sources, it is recommended to assess these in a watershed contaminant source document, WCSD, or a WCSD. And when you go about looking at background and non-Navy PFAS sources, the key issue here is you must consult your management and legal counsel if you suspect an area is impacted by a non-Navy source. Next slide. So the illustration on this slide helps depict pathways for PFAS migration that can cover long distances and large areas, and they can spread. So a lot of it is associated with particulate transport from dust and emissions that can redeposit particles with PFAS back into the environment, and these can be carried by the wind and rain over long distances and over large areas and diffusely, and it can possibly commingle with other sources of PFAS, becoming very difficult to disentangle from the PFAS release at our site. Contributions from these phenomena may be detectable in your site's RI media samples and possibly misattributed to your site release at your Navy site. Therefore, the key takeaway is that it may be really important at some PFAS RI sites to include upgradient and upstream reference samples in the sampling strategy. And also consider you may need a base-wide background study or WCSD to help achieve your project quality objectives. However, not many examples of these PFAS background studies exist right now and are accepted. Lessons learned, of course, will be communicated as we get them. And so, like I mentioned previously, work together with your SMEs and partnering teams to develop clear objectives and achieve agreement on how the RI data will be used. Next slide, please. So switching gears a little bit from all this talk about CSM and sample design is another critical aspect to planning and performing PFAS RI projects, and that is managing your investigative-derived waste, or IDW, effectively and in accordance with existing regulations and policies. So up front, if you are conducting a PFAS RI, all IDW must be analyzed for PFAS. It's a known release at your investigation site. It could be there in your IDW. There's no getting away from it. And because of the concern over PFAS and the emerging understanding of its characteristics, there are potentially federal, state, and local restrictions and requirements for the appropriate storage, handling, and disposition of IDW and any wastes containing elevated PFAS concentrations, even though it's not classified as a hazardous waste. Because of these constraints, storage, handling, and disposal costs per unit volume or mass of PFAS IDW are substantially elevated when compared to typical IDW costs at other RI sites, especially for amounts of non-hazardous wastes. So it's important that we evaluate approved IDW treatment and disposal options in accordance with the 11 July 2023 memorandum from the Assistant Secretary of Defense, and also the possibility of the most recent guidance when coming up with your IDW management plan for a site's PFAS RI project. Listed here are some of the best management practices to consider when planning your RI. These are not prescriptive or all-encompassing, but highlight some strategies that may be effective at your site. I'm not, just a quick technical check. I'm not seeing the update. Can you still hear me?
I can hear you, yes. And the audience can see slide 21.
Great. So going over the best, thank you so much. So going over the best management practices to consider when planning your RI. So these are not prescriptive or all-encompassing, but they highlight some strategies that may be effective at your site. But so in particular, I wanted to draw attention to waste minimization. Using a more expensive investigation method up front that will result in substantially less IDW generation and minimize IDW generation can ultimately offset its cost in significant project effort savings. So an example of this is drilling boreholes using sonic drilling technology as opposed to mud rotary drilling. I've had experience with this here in Nafak, Washington, and mud rotary generates a substantially more volume of IDW and requires containerizing associated drilling fluids and sludges along with the borehole solids when drilling is being conducted. It also requires substantially more liquid to decontaminate the rig between boreholes, and residual downhole drilling mud may also require a substantial amount of water to flush and develop the monitoring well at the borehole when compared to sonic drilling. As sonic drilling typically generates little to no aqueous waste and typically results in much less volume of IDW from well development in practice. And so the reduction in decontamination effort and is also important of the rig, the sonic rig versus a mud rotary rig between boreholes also has the advantage of resulting in less potential for cross-contamination. So yeah, the considerations are nuanced, and it's important to consider it as you're planning your RI, not after the fact. Next slide, please. So ultimately, the key, I'm just going to repeat myself, the key takeaway with PFAS IDW is to consider its cost and challenges early when scoping and planning your PFAS RI. And I wanted to round off discussing IDW to point out and emphasize the 4 treatment options for disposal of IDW that are contained in the ASD interim IDW guidance for PFAS. So it's limited, but it's at least accepted. So things like carbon reactivation units with environmental permits for you using granular activated carbon only, not resins. Hazardous using disposal at hazardous waste landfills with appropriate permits. There are cases where we've seen accepted disposal at solid waste landfills, but they must have composite liners with gas and leachate collection systems and treatment of those systems to ensure that PFAS is not migrating off site from your disposal area. It's still a problem, cradle to grave. And once the DoD moratorium on incineration is lifted, hazardous waste incinerators, also with environmental permits, may be used. But there are also innovative technologies being piloted, and they could be appropriate at your site. So again, consultation with your project team of subject matter experts, your regulators, management, and legal counsel will provide that critical support during your planning process and when conducting your RIs. And that's about all I want to say on IDW. And with that, I would like to end and turn the presentation over to Ramona Irie, who will lead the Q&A and wrap up. And she is also a fantastic Navy SME to consult when it comes to managing PFAS IDW at our sites.
Hey, thank you, Kendra and Alex. So we've been collecting questions submitted throughout the presentation. I encourage you all to submit any additional questions now through the Q&A box. So the first question I'll direct to Kendra. You mentioned guidance for off-base sampling. Does this include any offshore work?
Yeah, this is Kendra. So in general, the guidance was not written with that in mind. So we do sample surface water and sediment near our installations where we have a confirmed direct release to those areas. But at this time, we don't have any guidance that speaks to anything further than that.
Okay, so another question related to off-base. During the presentation, did you say that the approval process to collect off-base data to support completion of an RI can take up to a year? This is a 2-part question, if you want to answer that one first.
Yes, it can take longer than that. Yes.
Okay. So the second part of the question is, so what are the expectations as far as completing the RI if we need to go off-base to determine nature and extent?
That's a great question. I would say, it's not really a hard and fast answer. You need to do your best to obtain, the data off base to delineate where your release has gone, if that's where it has gone, if it's gone off base. And in some cases, you just may not be able to collect all the data you need. But as I said, there are different tools available for off-base delineation, such as the real estate actions, which are really more voluntary. You're getting the approval from the landowner to do the well install or whatever sampling methodology you're doing. Whereas the Circular 104E is a bit of a if all else fails, you know, we could do this action because we have the authority to do so. And it's not really a force to. It doesn't have to be used as a force to. It can be, sorry, it can be used as a tool to expedite the process because we do have the authority. So it's a very sensitive and really and complex thing that you just need to consider going into it. Sorry, fuck my dog.
No problem, and thanks, Kendra. So a couple questions here.
This is Kim.
Mm-hmm.
I just wanted to add a little bit to that response, if I could. This is Kim Brown at the headquarters. You hear me?
Yes, go right ahead.
Yeah. What I was going to say was the reason that we had mentioned that it could take an exceedance of a year is because when we go off base, it all depends on the I guess the extent of the sampling that we have to do. We normally, or usually our policy is to go basically within a mile off base, and it could be that the that there aren't as many properties within that mile off base. So it could take less than that time, but you know, there's you know, it all depends on how extensive the sampling area is. So we say that sometimes it can take over or up to a year because it takes time to actually have a public meeting, to conduct a public meeting, to see what property owners are going to allow us to sample their wells. So there's just some of the complexities that go along with that, but it doesn't necessarily have to take that long, but we just wanted to mention that time frame just to let our PMs be prepared that if we do go off base, if we do think that there's a potential that we do need to go off base, it could take a little bit longer, and we just want you to be able to know to prepare for that. But that's doesn't, if it ends up not being as many residences that have the private wells, then there won't be as much to sample, and it could take a lesser amount of time. So just wanted to add that clarification a little bit there.
Okay, thank you, Kim. So now we have a couple questions for Alex. So what are some potential strategies for identifying PFAS source areas if there appears to be a link between rainfall events and PFAS detections?
Yeah, I saw there was a lot of questions about assessing background. And this is where I have to default to consultation and working together with your SMEs and legal counsel in order to get that sampling strategy forward so you can disentangle background and other non-Navy sources from the release at your site that we're trying to address under CERCLA. It's not an easy, straightforward answer because, as mentioned before, we don't have a lot of examples of accepted background studies for PFAS, but we're working on them, and there are scientific papers out there which can provide some insight into how these background levels could occur at your site. So again, and this is also why you need clear and important, or you need clear and concise, and well, not concise, but clear quality objectives in your project. And part of that to touch on the watershed contamination source document, the guidance is still there and it's still in place. My understanding is that we don't have anything specific for PFAS yet, but it's important to have consultation, again, with your SMEs and legal counsel to perform these so you understand what your non-Navy sources could be that are affecting the non-release concentrations of PFAS in your environment, and avoid the appearance of pointing fingers, right? It's more so focused on delineating what is a PFAS release, what is a Navy PFAS release at a site, and what is not. All right, I guess I'm done answering those. I think I hit a few of those.
Okay, thanks. Coming back to you for this is a quick question. The moratorium, the RI guidance includes IDW disposal option of incineration. Has that moratorium been lifted?
As far as I know, no, it has not been lifted yet. But Ramona, if you know more or know more current, I don't want to misspeak.
Yeah, you're correct there.
Okay.
Yep, it hasn't been lifted yet, but once we get notified, I think we'll have 45 days. We'll be notified 45 days before it's lifted.
Yeah, Ramona, I think this is Jason. I think that's you're exactly right. There's going to be a 45-day notice that's going to be published on the OSD website prior to the moratorium ending. Kim, you can correct me if I'm wrong in that.
You're right. We just we did think that moratorium was going to be lifted a lot sooner. We had a memo back in July which said it's going to be lifted as, once and a notice will be put on the website within 45 days. And unfortunately, there were some political delays that came into play, and that didn't happen. So we still have been told that no, it has not been lifted. But we're thinking that once we get that notice, it will still state 45 days from the time that that they put something on their website, but it will be placed on the OSD website when that happens, and we'll also let our RPMs, our ER managers know, give that notification as soon as we hear anything from ASN and from OSD.
All right, thank you guys for chiming in there. So this is a question again for Alex. So you mentioned the properties of different PFAS. So this question has to do with how much precursor data evaluation is considered reasonable for a PFAS RI, knowing that precursor transformation is not yet fully understood. And does the Navy recommend using top assay for RIs?
I mean, essentially the default answer is what are the project quality objectives associated with your RI. This is where it becomes really important to evaluate all the SI information you may have before that. If precursors do end up being a data gap and are important, because one of the things from experience that I tried to mention in the slide is that you can have these down gradient increases in things like PFAS and PFOA, that have RSLs. And we're like, oh, is this indicative of another source? Well, take a step back, understand the CSM, your fate and transport. That increase in PFAS and PFOA may be site related if you can understand the precursors and the precursor level. Again, like a lot of the mechanisms I spoke about are still remaining conceptual because we don't necessarily have good analytical methods or field collection methods in order to really get something quantitative and defensible. So please, again, can't stress enough, PFAS is emerging and the technology is complex, and it's going to be different than what we're used to in performing RIs at other sites for other kinds of chemicals. And I think I should leave it at that. Oh, I'm sorry. I mean, as far as the top assay, again, that has to be a PQO. Because we have to stress that whatever results of the top assay, that the data has to be usable and ideally accepted. And if it's not worth it.
Alex, this is Jason, and I'll chime in on the top assay. One thing that folks need to realize is that there is no standardized method for the top assay. Therefore, and there is no ELAP approved laboratory for the top assay. So with that given, it's more of a screening tool if anything, that could be used as part of your RI and should not be used in a definitive nature. Thank you.
All right, thank you. So just before we wrap up, just one last question here for Kendra. So you mentioned ecological screening levels. Are these compiled in one document where they can be found, or which sources should we confer with for those?
Real quick technical, are people hearing us anymore? I have a comment that says audio is gone.
Okay, let me check.
I didn't mean to interrupt. I would just be concerned that we're going through this and the audience can't hear us.
Yep, I'll hold.
Okay, my feed still has audio.
Okay, so it could be a 1 or 2. Okay. Okay, this is Kendra, and I'll respond to the ecological screening level question. We do have an interim document that is available. I say interim because, you know, like I said, these things always change. But we do have one available, and we have used it in some RI SAPs, and we'll start using it in future RI SAPs where appropriate. So that document can be provided to you, whoever's asking this question. It depends on who it is, I'm sure, but it can be provided for information to understand what those values are and why those values were selected. So yes, please speak to your Navy RPM and get that information from them. Thank you.
All right, thank you everyone, and thanks for submitting questions, and thank you for our presenters for your thoughtful answers and for sharing your knowledge on RIs. So if you submitted a question today that we were not able to get to, feel free to reach out to any of the subject matter experts, our presenters and our subject matter experts directly at the email addresses shown on this slide. And next slide. So as we wrap up, please take the survey that will be emailed to you when you leave the webinar. The survey is just 4 questions and it should take 2 minutes or less to complete, and that provides us with valuable feedback. And stay tuned for our next OER2 through the T2 email. If you are not receiving our T2 email already, you can put a message in the chat box asking to be added to the list. Also, we post our recordings to the Go ERB website and YouTube page, so you can check it out at those locations. So thank you all again for attending this OER2 webinar, and we look forward to having you back next time.